my dear student, I'm Mr. Kitwala from Educators. I will be with you in physics for Form 5. So, welcome to proceed with our topic of rotation of a rigid body. For our subtopic of for our new subtopic, which is called the axis theorem of rotating bodies. Now we are going to see some theorem that exist when the body trying to rotate, when the body trying to rotate on an axis. That is what we are going to proceed for our today discussion. But before we proceed here, now we are supposed to remember where we ended on the last session. On the last session, my dear student, we tried to look about the how can we demonstrate the moment of inertia for the hollow cylinder. And we say that always the moment of inertia for the hollow cylinder must be equals to mass times the radius square. And we tried to conclude that always because the cylinder is categorized into two types or into two parts, which is the solid cylinder and also the hollow cylinder. We say that this solid cylinder have the moment of inertia which is less than the moment of inertia of the hollow sphere. That is what we tried to conclude. There are some conceptual questions you will interact with it, which is say that why we say that the moment of inertia of the solid cylinder must be less than the moment of inertia for the hollow cylinder. The reason is because of their mass distributions. The mass distribution of the mass distribution of the solid cylinder is closer to the axis of rotation. That is why it is very, very less. It produces the moment of inertia, which is less than the moment of inertia for the hollow cylinder. For our today discussion here, what we are going to look about the axis rotation, the axis theorem of rotating a body. There are so several theorems related with the rotation of the body on it is an axis. That is what we are going to learn for our today discussion. As we observe here, our statement said that the axis theorem of rotating bodies included the parallel axis theorem and the perpendicular axis theorems. So when we talk about the theorems that exist when the body are trying to rotate on an axis, there are only two theorems. The first theory is the parallel axis theorems. Now we are going to see how the body trying to rotate parallel on with an axis of rotation. That is what we are going to see for our today discussion. Also for the perpendicular, now we are going to see that how the body also try to rotate on an axis perpendicular with that that is what we are going to look for our today discussion. So this theorem are used for determine the moment of inertia. The aim of having these theorems is for the purpose of identifying or determining the moment of inertia about an axis given that the moment of inertia about the other axis are known. That we know that some moment of inertia for the other bodies are known. Now we are going to see that how by using the parallel axis theorem, can we obtain the moment of inertia? How the parallel theorems of the axis of rotation can be applied for the bodies that we try to look in order to derive the moment of inertia. That is what we are going to look for our today discussion. So let us start with the parallel axis theorems. There are some concepts related with the parallel axis theorems. Now let us see those statements related, and after there we will go and see the theorem which we should be asked to state it on our examinations. So the moment of inertia of a rigid body is easiest to calculate when the rotating axis align with an axis symmetry. So it is easy to calculate the moment of inertia for a rigid body when when it try to rotate on an axis for a symmetry axis. That is what we are going to look for our today discussion here. So, however, calculating it is about an arbitrary axis can be a difficulty since there are infinity possible rotation axes. As we know that the body on an axis should try to rotate on it is infinity. It means that the limit should be infinity, kwa sababu huwezi ukakaunti kwamba ni muda gani ile boti itaweza kurotate na mwisho wa siku ita relax on its axis of rotate. That is what we are going to look for our today discussion. So here let us go and see a rigged body has infinitely many moment of inertia. We are going to look that imagine we have the rigged body, and that rigged body should have the infinity many moment of inertia. Now how can we apply those moment of inertia? That is what we are going to proceed with here on our discussion. So the parallel axis theorem simplify this calculation. So this parallel axis give us the calculation related with the rotation of a rigged body on it is an axis here. So the parallel axis theorem state that. Now we are going to see how can we state the moment the parallel axis theory, because you should be asked on your examination to state the parallel axis theorem of the parallel axis theory of the rotation of the rigged body on it is an axis. Now, how can you state this law? That is what we are going to look for our discussion here. So our law said that so the moment of inertia for a rigged body at any point must be equals to the sum of the moment of inertia, so the center, then we add by the mass times their distance apart of their distance a square apart for those axes of rotation. That is how the law states. Now let us read our statement, but the overview of the law give us the relationship between the moment of inertia for any rigged body and also the moment of inertia for this through the center plus the product of the mass times the square distance between apart when we have the two axes that lie parallel to each other. So our law say that the moment of inertia of a rigged body about any axis is given by the sum. As I told you that moment of inertia through of a rigged body through any axis is given by the sum of the moment of inertia about through the center, or about a parallel axis through its center of of mass and the product of and the product of its mass and the square perpendicular distance between the two parallel axes. Now imagine we have the two parallel axes. That is what we are going to summarize this law. We have two parallel axes, and that parallel axis exactly on a rigged body. So we have been told that when we wanted to state those parallel parallel axis theorems, it said that the moment of inertia through any axis between those two parallel axes that are exactly on a rigged body must be equals to the moment of inertia through the center. Then we add by the moment of by the product of their masses and also times the perpendicular distance between the parallel axes. That is our law said. So as we see our demonstration here that the moment of inertia through an axis must be equals to the moment of inertia through the center, and then we add by their product of their masses and also the perpendicular distance between any two parallel axes. That is what our law said. So to prove the parallel axis theorem, consider a rigged body. Now we are going to see how can we prove this theorem. That is what we are going to look on our statement here. That how can you because we have understood the way we can state it. Now how can we demonstrate our our law. How can we demonstrate our formula of the moment of inertia through the parallel theorems and axis? So consider a liquid body of mass m rotating about an axis y located at a distance d from the center of mass g. Then consider the particle of mass I at a distance x from the center of mass g. So, my lovely student, here as we observe that we have been told that we are supposed to consider a liquid body, and that liquid body involve the mass m, that is trying to rotate about an axis y, then located at a distance d from the center of the mass g. Then we are supposed to consider the particle inside there. We have the particle mi, and also that particle is placed apart at a distance x, as we try to observe from the center of the mass g. That is what we are going to demonstrate here.